Guys, so today we'll learn the difference between valence electron and valency. So what is the definition of valence electron? So this is basically the electrons in an atom's outermost shell. Okay, so the number of electron of an element in their outermost shell is the valence electron. Now then, what is called valency? Valency basically the number of electrons in the outermost shell an atom can gain or lose, or it can share to form the chemical bond. Okay, so if you see one example for oxygen, oxygen has total 8 electron, right? So if you see the electronic configuration, it will be 2 and 6. Okay, now the valence electron, if we are denoting as VE, then it will have 6 electron, right? Because 6 electron it is present in the outermost orbital. Now if you see, then what will be the valency? Valency basically the electron needed to get the inert gas like configuration. So for oxygen case, it need only 2 electron in the outermost orbital, right? Then only it will have the 8 electron, and then it will have that configuration like inert gas of neon. Because see, oxygen has the configuration 2 and 6. So if it gets 2 electron, then what will happen? Oxygen will get the 2 negative charge, oxygen 2 minus, and the final electronic configuration will be 2 and 8, which is the configuration of neon. So by this way it will get the stability. Okay, so the valency here it is 2, but the valence electron it is 6. Okay, then how, when it will be same for valence electron and valency? It is same whenever the outermost electron, number of the outermost electron is 1 to 4. Okay, so if the outermost electron, let's say if we are seeing see for beryllium, beryllium has how many electron? Total 4 electron, right? So 4 electron, the configuration is 2 and 2. Then if you see the valence electron, what will be the valence electron? VE, it will be 2 only, and valency also it will be 2, right? Because if it is basically donating 2 electron, then what will happen? It can get the inert gas like configuration, which is like helium. Okay, so what we can see, if an atom has 1, 2, 3 or 4 valence electron, its valence is equal to that number, right? That time valence like valence electron equal to valency. So we can write this statement like this way: if an atom has 1, 2, 3 or 4 valence electron, then its valency is equal to the valence electron. Okay, right? Then we'll see for other example also. Let's say if it is chlorine. Chlorine has 17 electron, so the electronic configuration will be 2, 8 and 7. Now you see, so the valence electron here, the number of electron present in the outermost orbital. Okay, so here it is 7, but the what will be the valency? Then valency is 1, because chlorine needs only 1 electron to get the inert gas like stability. Let's say here chlorine has 2, 8 and 7. This is the configuration. If chlorine is accepting 1 electron, then chlorine will gain 1 negative charge here, and the final electronic configuration will be 2, 8, 8. So this is the configuration of argon, right? Argon has 18 electrons, so this is the configuration of argon. Here you see, here valence electron is 7, but valency is 1. Okay, then we will see for other example. Let's say for lithium. Lithium has how many electron? There are 3. So the configuration it will be 2 and 1. Now if I am asking you that what will be the valence electron, here you see valence electron will be 1, which is equal to the valency, right? Because here we have written that statement: if an atom has 1, 2 or 3 or 4 valence electron, that time what will happen, valence is equal to the valence electron, right? That is what we are getting here. So first what we have to check is that the number of valence electron. If it is below 5, that means if it is 1, 2, 3 or 4, let's say for carbon has how many electron total? It is 6. So the configuration is 2 and 4. Now you see the number of valence electron, it is 4. No, and which is the valency, right? So valency also it will be 4. So what we have to check is that first we have to check the number of valence electron. We have to get the electronic configuration, then you have to get the number of valence electron. If it is below 5, that means if it is 1, 2, 3 or 4, then the valence electron and the valency will be the same. Okay, so if it is from 5, 6, 7, then the valence electron and valency will be different. Let's say for again any other example, let's say for sodium has total 11 electron, so the configuration it will be 2, 8 and 1, right? See here 1 electron in the outermost orbital, so the valence electron which is equal to the valency which is equal to 1. Okay, now if you see for sulfur, so what is this electrons number of sulfur? This is 16, right? So the configuration will be 2, 8 and 6. Now it says it has 6 electron in the outermost orbital, which is more than 4, right? So then what you have to do? So first you have to get the valence electron, which is basically 6. Now how will you get the valency? So this is basically 8 minus 6, which is 2. Why we did 8 minus 6? Because it has to have the 8 electron in the outermost orbital to get the inert gas like stability. So the valency is 2. Okay, so in this way we can do for any element, and we can get the difference also in between valency and valence electron. So please, if you have understood this concept, please write the comment, or you can like also, and please do not forget to subscribe the channel. Thank you so much. So next day what we'll do, we'll discuss some other topics, and you can suggest also what are the topics need to be discussed. Thank you once again.